Hello everybody, this is the third video clip for the first chapter, which is about the limit, okay? So for this video clip, we are going to calculate the limits using the limit law, okay? So let's see what is the law look like. It is saying that if your f and your g, okay, having the limit as your x goes to a equals to L, and the g having the limit as your x goes to a equals to m, okay. This a is a real number or a symbol positive infinity or negative infinity, but your L and your M are real numbers, okay? Then we are going to have, actually the first one that involves the L and the M is this second item. It is saying that if you have a limit of two functions added or subtracted, okay, and both of them, the limit exists, then it means that you can find the limit of f and a limit of g separately. After that, you just doing the addition or subtraction corresponding, okay. If the another one is that if you have a constant c, okay, this c is a real number multiplied by a function f, then this constant can be pulled out from the limit, and then you just calculate the limit of a function f itself, okay. So this one, and then later on you just attach this c, multiply the L right there, okay. Another one is that if you have a limit of two function multiply, again each of them limit exists, then you can find a limit of your f and your g separately. After that, you just let them multiply together, okay. So all these numbers, all these items are just saying that, hey, if you have addition, if you have multiplication, if you got a scalar multiplication, you can just separate your limit, okay? Okay, and then you just find the limit of each of the function, okay? And then after that, you just do the same operators, okay? So on number 5, okay, this is another one that is very important. If you have two function uh, divided like that, okay, your f of x divided by your g of x, and you let your x goes to a, if both of them limit exist, you can also kind of separate uh, the limit over the division as well. However, they will have one of the most important uh, condition is that your m, the bottom, cannot be 0. So if the bottom is 0, then what happened? We are going to study later on, okay. And if you are having the f of x raised to power m over n, okay, and your function has a limit as your x goes to a equals to L, you can just it's look like the limit go inside that uh, power, that exponent, okay. So it becomes L raised to power m over n. However, this L raised to power m over n must be a real number, okay, in order to make this equation valid, okay. So what is the first item that I just skipped? Actually, the first item is pretty easy. It's saying that if you talk about a limit of a constant, it will be that constant itself. Why is that? Okay, because if you talk about a constant c, so it means that this is the curve, the graph of that of a constant function. So either, I mean, if your a is right here, okay, either you go from the right or from the left, okay. So it will the function value are steady as that value c, okay. So it will, the limit will goes to that c, okay. So by the same token, actually we can have like, let's say number 1.5, okay, that if you talk about like y equals to x or fx equals to x, which is the straight line that doing 45 degree with the x-axis from the positive x-axis, right? Okay, this one. And if you're talking about like any number a here, okay, so it means that as you go from the left, okay, from the right, it will go close to this function value. As you go from the left, it also go close to this function value, right? And what is this function value? The function value of this one, it is the same, right? If you input x, the output will be x, same thing. So if you input a, the output will be a as well. So it means that the limit as your x goes to a of a function x, it is a. So what does this mean? It pretty much look like you just plug in your x as a in this function, right? Why is that we can do? Because remember previously, the previous video clip, we say that, hey, this graph is actually continuous at x equals to a, right? So the limit and a function value are the same, remember? So this one equals to f at a as well because the function is continuous, okay? And actually all these rule, okay, number 1 to number 6 are applied as well if your x goes to a from the left or your x goes to a from the right, okay? We can have the same theorem, okay, if you just change instead of two-sided limit into a one-sided limit, either the left hand side or the right hand side. Okay. So we also have this kind of theorem as well from a deductant from that from the previous one, is that if your f and your g are function that which are continuous at this particular point x equals to a, and your a is real number, then the addition or subtraction of the two continuous function, a multiplication by a scalar of a continuous function, or a multiplication, a product of two continuous function at the point, still continuous at that point a, okay, because the limit can separate, and for continuity, the limit at this point equals to a function value at that point, right? And the function value of these algebraic functions, okay, like the corresponding operator, like for example, at f and g at a, it is the same as f a and g a. Okay, so they act the same as the limit law here, right? That your limit can be separate. So your f and g can be separate as well. So they must be the same. Okay. However, for the division, the thing that you need to be careful is that your bottom, again, your g at a is not going to be 0. Okay. Okay. And the theorem also saying that if we talk about a polynomial function, actually this one constant or a function fx equals to x is actually one of the examples of the polynomial function. Okay, and a polynomial function, the whole thing can be a n x to the power n plus a n minus 1 x to the power n minus 1, etc., to a1x and then a0. Okay, this one is continuous at any point x equals to a. So what does this mean? This means that if you want to find the limit, okay, of a polynomial, okay, of a polynomial, then it is the same as you just evaluate a function value at that particular point. Okay, so it is pretty much the same as like plug in. Okay, and the rational function, so if you have like two function divided each other and both of them are polynomial, they are also sorry, this one a typo. Okay, so this function is continuous at each and every point x, okay, except the point where your qx, the bottom, is 0. Okay, so it will continuous at each and every point x such that your qx is not equals to 0. And also, this kind of function, a power like that, x raised to power m over n, it is also continuous at each and every point x equals to a in the domain. Okay, so what does this mean? So it means that this one as well, if you want to find the limit as your x goes to a of your px over qx, it is going to be pa plug in over QA, okay, just plug in X as A. Whenever your QA is not 0, your bottom cannot be 0. And this one, if you want to find the limit as your X goes to A of X raised to power M over N, I mean, actually this one is one of the limit law, right? It will be A raised to power N over M, just like plug in, okay? Whenever this one, it is a real number. If it is not, then this equation is not valid. Okay, so let's try this example. Okay, so look at this example. Actually, this is two function multiplied. Okay, and then you see that one of them, if you plug in 3, okay, you got 5. If you plug in 3, you got a sine of 3 pi over 2, which is -1. So both of them, the function value exist. Okay, actually this one can be just multiplied, right? So it is the same as what? The limit as your x go to 3 of x plus 2, which is a polynomial, and the limit x goes to 3 of the side of x pi over 2, which is the trigonometry. And this one is actually one, the graph will be one piece, right? You can try to draw this kind of curve. Okay, this one is also continuous, okay, at each and every x. Okay, especially when your x is 3, so you have this one as 3 plus 2, and then this one you just plug in as 3 pi over 2, so you have 5 and -1 multiplied together as -5. Okay, so it's look like you plug in, okay, but actually this one can happen because your function under consideration is continuous. Okay, so this one as well, this one is continuous, this one is also continuous, this one is just a constant, right? Okay, so you are going to have what? 5. Okay, so you are going to have a limit as x goes to 2 of 5, the limit as x goes to 2 of absolute value of x, and then the 2 can be out, and then the limit of this one, x squared. Okay, and this x squared is simply a polynomial, right? So you have 5, you have 2 square. How about this one? This is like something that you really need to talk about, because the absolute value of x is really not a polynomial. Okay, so the absolute value of x can take a value of x. If your x is positive, it can be negative x if your x is negative. And this one, your x go close to 2, so it means that the 2 is right here, the 0 is right there, and it go really close to 2. Okay, either way, so it will be like the positive side of the x, right? So it means that this limit, I mean this absolute value function under this consideration, it will take a value x. Okay, so it will just be a polynomial x, right? So as your x goes to 2, then it will goes to 2 as well. Okay, so this one will be 5 and 2 is 7, and then minus what? 8, right? So it's -1. Okay, and if I calculate wrong, then please let me know when we meet together. Okay, and that usually the case that I always do it wrong. Okay, so let's take a look at this one. So let's pretend that we separate it. Okay, just like that, because the top and the bottom, they are both polynomial, right? So let's pretend that we can separate it. But if we can really separate, it means that the limit of this one, the one at the bottom, is not 0, right? So let us evaluate. Okay, as your x goes to -1, this is only a polynomial, right? So it will be -1 square, 3 and -1, and then -4, is it? So here's 1, and then +3 -4. Oh, it is 0. Okay, okay. So it means that you cannot really doing the separate of the limit, okay, over this division. All right. So this means that this one is wrong. Okay, if you do it this way, it's wrong. Okay. However, can we manipulate a little bit, okay, to really finding the limit? You remember what we have been doing, the x squared minus 4 over x plus 2. You remember this kind of gx, and then your x is not -2, right? So this one as well, under the consideration of the limit, okay, it means that your x can never be -1. Okay, your x can never be -1. So let's try. Hey, this one we are not, is not that difficult, right? This one's actually the limit as your x goes to -1 of x minus 1 and x plus 1. And then because right here, as you plug in -1, then you got 0. If you don't know how to do a factorization, actually you know already that if your polynomial of something equals to 0, it means that that polynomial equals to x minus a multiplied by another polynomial already. So it means that you plug in -1 here, and then the bottom is 0. So you already know one of the factor. And if you know one of the factor, here's -4. So it must be a -4. And then you just check, okay? So here's x, here's -4x. So you got -3x as a middle term, okay? So it means that this one is valid. And again, don't forget, because under this limit consideration, your x can never be -1. So your x plus 1 is not 0. So here is not a 0 number. There's not a 0 number. And you got two of them as a top and the bottom. So you can actually cancel, right? So the leftover, it is a limit as your x goes to -1, x minus 1 over x minus 4. Okay. So now again, polynomial, right? So you try to separate, okay? So you have x minus 1 over the limit as your x goes to -1 of x minus 4. So as you plug it in, you have what? -1 and -1, and then -1 and -4. So you have -2 over -5, or 2 over 5 as a limit of these fractions. Okay. And actually, I mean, if you guys are so good, you don't really need to do it like this kind of, this tedious. Okay, so later on we are not going to do this kind of tedious calculation. Okay, we are going to do it faster than this. Okay, and if you guys are so good, you don't really need to go through all these details. Okay, sometimes you can jump from this one to here, and then from this one to there, and then from here to the end, okay, to the answer, okay, because it is not that difficult. Okay, so let's, how about this one? Okay, again, by the way, if you take a look a little bit at this problem, okay, it's not only the bottom that is 0, but also the top that is 0. Okay, so this means that if, okay, the limit as your x goes to a of your f of x over g of x, okay, as you do the plug in, okay, as you do the plug in, it equals to 0 over 0, then you need to do a manipulation. Okay, okay, and some manipulation may help you to be able to determine the limit. Okay, okay, so it is not that, hey, I mean, because the bottom is 0, then thing collapse. Okay, but we can try to play with it a little bit, and then later on, after doing a manipulation, sometimes you may be able to determine the limit. Okay, so for example, this one, if you plug in your x as 0, the top one you have square root of 4 minus 2, which is 2 and 2, so it's 0. And this one, of course, 0 square minus 0, so it is 0, right? So this one, okay, after you plug in, you have 0 over 0. So it means that you need to doing a manipulation a little bit, okay? And as you see a square root, a manipulation that you may think of is this one, okay? This one is so-called the conjugate, so that it will get rid of the square root, okay? Because you can see that you already have a minus b, right? So if you just multiply more by a plus b, the square root will be gone because you have a square minus b square, okay? So this one, you are going to have this one copy and then multiply by a plus b, right? Of course, if you multiply by this one to get the thing equal, because you need it to be equal, you just divide it by the same thing so that it look like you multiply by one, so everything will be the same, right? And your bottom can manipulate a little bit by pulling out the common factor, right? So what is your top going? So it's going to be a square root square, so you have x plus 4 minus a 2 square, and then x minus 1, and this square root, okay? So here is a common mistake that you forget. I mean, this one you are not going to forget, okay? This one you will write, but then as you do, as you continue, you keep forgetting the one that is left over, okay? And another thing is that please don't really multiply it out, okay? Leave it like that, okay? If you do multiply it out, then it will get you like to the worst scenario, okay? Okay, so just keep it multiplied like that. So here it happened that your 4 and 4 canceled. So on your top, you have only x left. And again, under this situation, it means that your x is not 0. So it means that their number, okay, which is not 0, they can just simply cancel. So what happened on your top, okay, you still have 1, okay? So because everything cancel, but you still have 1 left, not 0, okay? And then this one on your bottom, you have all this, right? Okay, and then now you can just simply do a plug-in, okay? On your top you got 1, on your bottom you have -1, and then this one, as your x goes to 0, you got square root of 4, which is 2, and don't forget this 2. So you have what? -1/4 as the limit of these fractions. Okay, okay. So how about what if we do something that is more complicated? Okay, let's try 2 here. So you have 2 multiplied by 1, it's 2. Let's try 2 here. You have a square root of 4, which is 2. So on your top, it is 0. How about on your bottom? So you have a 4 and a 2 and a 6, right? So of course, it is a 0. So you have like that, okay? So again, you see the square root again. So you think of this kind of manipulation, right? To use the conjugate. So this one is so-called a conjugate. All right. So the first one, you just multiply it by the same thing, right? But using the addition, okay? How about your bottom? We just saying that, hey, your bottom is also 0. So it means that one of the factor must be what? X minus 2. and this is -6, so it must be x plus 3, and then you just do a quick check, -2x plus 3x, so you got a middle term x. Okay, and don't forget that if you multiply by this one to get it equal, you need to divide by the same thing as well. Okay, you see, so this whole thing is look like you multiply by 1. So what happened to your top? It will be the a square. So don't forget that you have 2 here. So you have 4x minus 1 subtracted by the b square, which is 6 minus x, over x minus 2, x plus 3. And as I told you, don't forget this extra term that you need to carry on. Okay, so what is it on the top? Okay, just the top. This was 4x minus 4, and then this is minus 6 plus x. Okay, don't forget plus x. So the x will be like 5x minus 10, which is what? 5 and then x minus 2. Again, your x goes to 2, so it means that your x can never be 2, so your x minus 2 can never be 0. So this one can just cancel, but you still have 5 left. Okay, so here what you have left, it is a 5 over x minus x plus 3, and that square root added, right? Okay, and then now you can just try to plug in. So you plug in x as 2, so you have 5. You plug in x as 2, so you have 1, and then square root of 4, which is another 2, so you have 1/4 as the limit of these fractions. Okay, so you see how we manipulate, okay, using the conjugate and doing the factorization. Okay, how about this one? Hey, let's see this one. Of course, I mean, you can plug in the top. You have 4 over 4 minus 1 over 1. So it is 0 on top, right? And also this one, 2q is 8. So it is a 0 on bottom as well. Okay. So can we simplify a little bit? So this one, okay, you do this one first. So here you have 2x, x minus 1, minus 1, x plus 2. Okay, you do the cross multiply, okay, over x plus 2 and x minus 1. And then because this one is divided, so you need to divide it more by x cubed over 8. Okay, so what is your top? Your top is 2x squared minus 2x minus x minus 2. Okay, so it is a 2x squared minus 3x minus 2. Okay, you can check again one more time that if you plug in 2, you have 8 minus 6 minus 2, which is again 0. Okay, so what does this mean? The one on top, you have x minus 2 as a factor. Okay, so you got x minus 2, and then because here is a 2, so you have 2x minus 1, right? Because this is already 2. Oh, plus, right? So here you have negative 4x and 1x, so you got negative 3x over this whole thing. But you remember this one? This is the difference of the cube, right? Which is what? A cube and b cube subtracted equals to a minus b, a squared plus ab and b squared. Or if this is a plus, this is a plus, and this one is a minus. Okay, so here because of the minus here, so you have x minus 2 and then x squared plus 2x and 4, right? Okay. Okay. So here again, this one, it means that your x is not 2. So it means that your x minus 2 is not 0. So this one canceled. After cancel, try to plug in again. So you have 2 and 2 plus 1. This one you got 4, you got 3, you got what? 2 and 2, no, sorry, 2 square. So you have 4 and 4 and 4. Okay. So on top you got 5. At the bottom you got what? 12 and 12. So it's 144. So that will be the limit of these fractions. Okay. This one, same thing. Okay. As you plug in 3, you got 2 minus 9 minus 5. So it's 2 and 2 is 0. As you got plug in 3, so you have 2 minus again 9 minus 5, right? So it is the same 0. Okay. So try to manipulate. Okay, I'm not so sure whether we have the enough space or not. The first one, you multiply by a plus, right? Right. And then this one, you also multiply by the same thing, right? So, and then this one is for your top. Okay. How about for your bottom? You have 2 plus, okay, and also 2 plus. We're right. This one is for your bottom. Okay. So now just multiply the one that we can do. Okay. So it means that we are going to multiply this one with that. Okay. So you have a square, which is 4, and the square root square. So we have this one. Okay. And this one we still have left over 2 plus 3x minus 5 over. And then you can multiply this one with that one right there, right? So it is a 4 again, and then 3x minus 5. But we still have this one left over. So just copy, don't forget. Okay. So what is it here? This one here, you have what? 9, right? So you got 9 minus x squared. This one here, you also have 9 minus 3x, okay? Or it is a 3 minus x, right? Okay. So it means that you need to manipulate a little bit more, because 9 minus x squared is just 3 minus x, 3 plus x. This was 2 plus square root, just copy over. This one is a 3 minus x, and then 2 plus a square root of x squared minus 5. So here your x goes to 3. So it means that 3 minus x is not going to be 0. Okay, so you can cancel. So, and then after that, you just plug in 3 here. So you have 6. And then 2 plus what? Square root of 4, right? Which is 2. And then here you have another 3. And then 2 plus square root of 4 again, which is another 2. So again, thing cancel. So you have just 2 left as a limit of these fractions. Okay. So it's just a matter of, manipulation by using the conjugate and also to factor. Okay. How about if you want to find a left or the right hand limits? Okay. For example, this one with the absolute value again. Okay. The absolute value of x we already know, right? But this time is not the x. Okay. It's like a box. Okay. it will be a box. If your box is positive, it will be a negative of a box if your box is negative, right? So right now here is your box. So it means that so let's see, it means that your absolute value of x plus 2 will be the x plus 2, the box itself. If your x plus 2 is positive, a negative of x plus 2 if this one is negative, right? So this means that this one will be greater than or equals to negative 2, but this one will be less than negative 2, okay? But for this function, your x cannot be negative 2, right? So it means that this function is actually x squared 3x minus 10 over a positive, over x plus 2, whenever your x is greater than negative 2, you see, it cannot be equal. And then x squared 3x minus 10 over negative of this function whenever your x is less than negative 2, okay? Do we think that we can manipulate a little bit more? So just try. Because you need to evaluate at negative 2, right? So just try negative 2 here. So you have a 4 plus 6 minus 10, right? You see it is 0. So it means that this one has a factor of x plus 2. So actually, this one is x plus 2, x minus 5, right? Okay. And this one, because your x is never be negative 2, so it means that these cancelled. So actually, it is x minus 5 if your x is greater than negative 2 and negative of x minus 5, because this one, same thing, right? Same thing, but you cancel with that one, we still have negative left over. So your x is less than negative 2. So it means that if you want to find a limit, okay, of this one, so it means that your x is less than negative 2, right? A function that we are going to calculate the limit will be the second one, you see? This one correspond to this one, so you use this function. And then you can just plug in, right? Okay, which is 7. And another one, if you want to find the right hand limits, okay, so it means that your x is greater than negative 2, so it corresponds to this one, which is using that formula, okay. So for x minus 5, you have negative 2 minus 5, which is negative 7. They are not the same. So what does this mean? So it means that this limit, okay, the limit of your x of your function f as your x goes to negative 2 does not exist. We get, okay? So how about whether it continuous or not? Okay, you find the answer by yourself. All right. How about this one? Okay, we want to say whether your f is continuous at this particular point x equals to 1 or not. So we need to check something first, whether f1 defined or not. Oh, it's right here. Okay, so your f1, it just happened to be 1 minus 1 over 2, which is 0. Okay, and then we need to check whether the limit as your x go to 1 from the left and the limit as your x goes to 1 from the right, are they the same or not? Okay, so let us check this one. All right, so if you want to find x goes to 1 from the left, so it means that your x less than 1. So again, your x less than 1 correspond to this formula, right? We're using this one. So it is a limit, okay, of x minus 1 over 2. So you just plug in again. Don't forget that this superscript is just saying that like which direction we are considering. So to calculate, this one is not has nothing to do with the calculation. So you still plug in 1, okay? So you got 0. And another one, if your x goes to 1 from the right, okay, so it means that your x is positive, sorry, greater than 1. So we are going to use the formula corresponding to x greater than 1, which is that formula. So you have x goes to 1 from the right of 2 minus x squared, which is again just plug in 1, nothing to do with that positive. So we have this one, which is 1. They're not the same. So what does this mean? The limit as your x goes to 1 of your function does not exist. If this one does not exist, so it means that your f is not continuous, because in order to be continuous, this one must be the same. So the limit must exist, and they must be what, equal with the function value. Okay, so actually I would like you to draw a graph. Okay, draw a graph of this function and see what happened. See what happened. Actually, this one is a parabola, right? Okay, and this one is just a straight line. Okay, you can look at the behavior of this parabola and this straight line. Okay, and why is that this function is not continuous? Okay, so how about this one? This one is saying that whether, I mean, we would like to check whether your f is continuous at x equals to 0 or not. Again, right here, your f at 0 is already defined to be -2 and then 3 over the absolute value of -1, right? So it is what? It is 1. Okay, it is 1. So the thing that we need to check is that the limit as your x goes to 0 from the right and the limit as your x goes to 0 from the left. Okay, because the 0 is like the point that your function using a different formula. Okay, so let's first using 0 from the right. Okay, so it means that this formula is corresponding. So we are going to find a limit of this square root. Okay, and then we can just simply plug in step 1. But if you going to 0 from the left, okay, so here is the corresponding formula because your x is less than 0, right? So here you have -2 and then x minus 1. Okay, actually we can just, plug in. Okay, however, this absolute value you may really need to consider a little bit. Okay, the absolute value of x minus 1, okay, can be this one if your x is greater than 1, can be negative of this one if your x is less than 1, right? And right now we are considering 0. The 1 is right here, and we are going from going to 0 from the what, from the left. You see, from the left, so it means that it is also on the left of 1 as well. You see, this corresponding to this one here. So if you want to really take out the absolute value, okay, this one must be what, negative x minus 1, right? Because it corresponds to this formula here. So as you plug in 0, you have -2 and then 3 over -1 and then negative again. So you have 1, right? Which is 1. What happened? They are the same, and they are the same as the function value. So it means that the limit as your x goes to 0 of your function here is 1, and it is equals to f at 0. Sorry. So it means that your f is continuous at x equals to 0. Okay. Okay. For this one, it will be difficult if you want to draw a curve. Okay. So I'm not going to ask you to do that. All right. How about what if we have this limit with several absolute value. Okay, so here the absolute value of x, okay, it is the x if your x is positive, negative x if your x is negative, but your absolute value of x plus 1, it will separate at x plus 1 if your x plus 1 is positive, right? So if your x is greater than or equals to negative 1, and negative of that thing if your x is less than negative 1. And this one, the limit is finding as your x approaches negative 1. So here, negative 1, there is 0. So if you go from the left of negative 1, you need to use this formula. If you go from the right of negative 1, you need to use the above formula. However, either way, the left hand side of negative 1 or the right hand side of negative 1 still is the what? Still the left hand side of 0, you see. So it means that the absolute value of x, okay, will be, I mean, if you get rid of the absolute value, you need to use this formula, because under this consideration is always on the left of 0. Okay, so here this limit you need to separate by yourself, okay, to the left hand side, which will be negative x plus x squared minus 2 over, so on the left hand side you use this one, right? Okay, you use this formula, which is negative x plus 1. Okay, so you just, roughly speaking, try to do negative 1 here. So you have 1 plus 1 minus 2. So it means that your x plus 1 is one of the factor there. Okay, so you have x plus 1, and then you need negative 2. So you have x minus 2. Okay, you check again. You have x and negative 2x. They have negative x as a middle term. And then this one, your x plus 1 cancel because of the limit, right? Is it means that your x plus 1 is not 0. So this is the leftover with negative. So as you plug in, so you have 3. And other way around, okay, the limit as your x goes to negative 1 from the right, you still, the absolute value of x still negative x, and this one over this one will be x plus 1. We use this formula instead. Okay, but then because this is the same, right, so we have the same factor, but the bottom are not the same. So here after cancellation you have negative 3. They are not the same, so it means that this limit of this function actually does not exist. Okay, so this is like one of the techniques, okay, several techniques actually, to find the limit of a given function. Okay. We are going to stop this video clip right here first, and then we will continue with the next technique that is not you may never think of, okay, that, oh, we can use this kind of thing to find the limit as well. Okay, so we'll see you on the next video clip. Bye bye.